when these are the answers. X equals -8, x equals 2. And we said we would just reverse the process. That is, we got these answers by factoring. So we put two sets of parentheses. Now we know our x is there and there. So if it was -8, originally it was a +8. And here, if this is a +2, it was a -2. So if we were to solve it in finding the zeros, would equate this factor to 0 and this factor to 0. And when we did so, x would be a -8, x would be a 2. But what was our original equation? This is in factored form. So here we'd have to FOIL this. X times x is x squared. Our outers are a -2x. Inners a +8x, which would leave us with a +6x. And our last term, -16, equals 0. So that is our answer. Now, let's suppose that instead of just having these two, we also had a 0 as an answer. Well, there we would just have an extra x out there, that this x would equal 0. But what would then be your equation? Well, you'd have to multiply these two together by FOIL to get this, and now distribute the x. So your final answer would be x to the third plus 6x squared minus 16x equals 0. So taking it in reverse, if you saw something like this initially and you were asked to find the zeros, you would factor out the greatest common factor, which would be an x. And then you would get this step, that you would then factor this into its factors, then equal each of the factors to 0, and then you would get your 3 answers. Okay, so this is a pretty good review then of this topic of, if you have the answers, how do you get the original equation? And we're going to do another one in which we use the technique of completing the square. And something like that. Okay. I was working on this example today in which these are the answers, and we're looking for what was the original equation of this. So this is a little bit different than one we've done in the past. So actually for this one we have to use the process of completing the square. So let's see if we can go backwards a little bit. So this side would have looked a little bit like so. We're going to take this 2 and bring it over in here as a -2. So you recall when we completed the square, we took the square root of this side and plus or minus the square root of the other side. And we got something like this. So we're going to see what we had over here. Now over here we would have had a plus or minus the square root of 21/9, but without the radical sign. So we'll take away the radical sign and we'll just put 21/9 there. And now we'll keep undoing things. So we're actually going to expand this into its form of x squared minus 4x plus 4 equals 21/9. And now what we need to do is take this 9 and bring it over to this side. And we're multiplying both sides by 9 here. So these cancel out. And now we get rid of our parentheses. We get 9x squared minus 36x plus 36 equals 21. So now we're going to integrate this 21 by transposing it to the other side. And we get 9x squared minus 36x, subtract 21 from both sides, and this gives us a plus 15. Now in a sense, this would be a good original equation. And in fact, that's what I got initially when I did it. When I put it into MATLAB, it didn't accept this one. And I think the reason is that this could be simplified by dividing each term by a 3. So that gives us then the final answer of 3x squared minus 12x plus 5 equals 0. But notice that this answer and this answer are of equivalent equations. But that was the process we use when we are given these as our answers, to reverse the process, and I used completing the square for it. Okay, just a little review.